Hello, in today's video we will be looking at how to find the vertex or the lowest or highest point in a parabola. For this video you will need to be efficient at completing the square. If you need a refresher on completing the square, I will link a video in the description detailing all of the steps and information required for doing so. However, if you're confident and efficient with completing the square, then we'll get started. So let's recall what the standard equation for a parabola is. And that is our basic equation, y equals ax squared plus bx plus c. From this equation alone, it's very hard to identify what the vertex is of the parabola. Again, the vertex being the lowest point or the highest point. So if we look at a graph, the vertex will be this point located here or this point located here. From this equation alone, it's very hard to determine what that vertex is going to be. So with a little bit of equation manipulation, we'll be able to get it in the standard equation for a parabola with a vertical axis. And within that standard equation, we'll be able to identify what the coordinates are of our vertex. So how do we do that? If we complete the square, we know that we really want to focus on this term alone. And to do that, we need to get this first term with a value of 1 in front of it. So what we need to do is take out the a. If we take out the a, then we're left with a and then x squared plus b divided by ax. We have some constant plus c. Next, what we do to find the squares, we take this b term, we multiply it by 1/2, and then we square it. When we do that, so if we take b divided by a, multiply it by 1/2, and then square that, we're going to be left with b squared over 4a squared. And this is the term that's going to go here. If we add this term to the right-hand side, we'll need to add that same term to the left-hand side, but because we're trying to keep everything on one side, we're going to subtract it to move it all onto the same side. And so therefore, we're going to be left with a multiplied by x squared plus b over a x plus b squared over 4a squared, and then plus c minus b squared over 4a squared. Now that we've completed the square and have moved everything to the right-hand side so that this is still equal to y, or our function f of x, what mathematicians have done to simplify the problem, they have made it so that h is equal to negative b over 2a, and that k is equal to c minus b squared over 4ac. And when you substitute these variables in for those values, then this can reduce to a equals x minus h squared plus k. And this is the standard equation of a parabola with a vertical axis, where h and k is your vertex. Again, what we did was we started with a standard equation for a quadratic, and then we completed the square. When we complete the square, we keep everything to one side or the right-hand side. And then what we've done is substituted that negative b over 2a with h and k for c minus b squared over 4a squared. And this is just to simplify it, because h and k are always those values when dealing with a quadratic equation. So instead of writing all of those terms multiple times, if you simplify it into h and k, it just makes life a little bit simpler. However, in this form of the equation, we're able to determine 1, the vertex at h and k, and then 2, if a is greater than 0, then we know that the graph is going to open upward, and if a is less than 0, then we know that the graph is going to open downward. So that's going to be the difference with this one here, a is greater than 0, and in this graph here, a is less than 0, or a negative value. And that is the information we're able to obtain with this equation. Okay, let's look at a couple of problems. All right, looking at our first problem, we have the function f of x equals a negative 3/4 x squared plus 9x minus 34. And the question is to find the vertex of this parabola. If we were given the standard equation for a parabola with the vertical axis of ax minus h squared plus k, then we would be able to use the value h and k as our vertex, and that would solve the problem. However, we're given this equation as the standard equation for a quadratic, and so what we'll need to do is we'll need to complete the square. When we complete the square, we'll be able to transform this equation into this equation, allowing us to find those values of h and k and be able to answer this question. So first, we'll need to complete the square, and when we complete the square, we will look specifically at these terms right here, leaving this negative 34 out, and then working with that later. When we complete the square, we need that x squared to be by itself, so we need to factor out that negative 3/4. When we factor out that negative 3/4, we're left with x squared, and when we factor out a negative 3/4 from that 9, all we'll need to do is just multiply it by its reciprocal. So 9 times 4, which is 36, divided by 3 is 12. And that was a negative sign, so that's a negative 12x. Just to check our work, if we multiply negative 3 times negative 12, that's going to be a positive 36. Divide that by 4, that's going to give us 9. So that's correct. And then we're left with some blank spot here. And then we have that term minus 34 out there. What we need to do is take that middle term, divide it by 2, square it. So then that's going to be 12 divided by 2 squared, and that's going to give us 36. That's going to be our term here. When we add 36 to this side, we need to be very careful because it's not just 36, it's actually 36 multiplied by negative 3/4. When we do that, we get 36 times 3, which is equal to 108, and 108 divided by 4 is equal to 27. And don't forget that negative sign. So really, we've added a negative 27 to this side, so we need to add a negative 27 to this side. Because remember, this is actually equal to f of x. And because we want to keep everything on the right-hand side, this negative 27 that was added, we're actually going to move over and add it back to the 34. When we do that, then we have negative 3/4 x squared minus 12x plus 36 minus 34 plus 27. When we write this in factored form, we get negative 3/4 x minus 6 squared minus 7. Now, this equation matches the standard form of a parabola with the vertical axis, and therefore we're able to determine what the vertex is by the point H and by the point K. So the vertex of our function f of x is located at 6, negative 7. Remember that k needs to be a positive k. We have a negative k, so we need to change that sign to match. And then that h value, it was a minus 6, so we're good there with the sign. But this would be the vertex of the function, negative 3/4x squared plus 9x minus 34. All right, let's look at another example. In our next problem, we are given this graph with a vertex of negative 2, 4. We see that it's going down, and it looks like we have x-intercepts at negative 5, 0 and at 1, 0. And the question asks us to find the standard equation for parabola shown in the figure. We already know what the equation for a standard parabola is. F of x equals a multiplied by x minus h squared plus k. If you don't remember how to solve for this, again, you can take your standard equation for quadratic and then complete the square, and that's going to derive this equation right here. But with this equation right here, what we know for sure and already is that one, our a value, because the graph is going down, our a value is going to be less than 0. And we also know that we are able to determine what our vertex is by identifying what h is and what k is. Well, we see in the graph here that they have given us the vertex, or in this case, the highest point in this graph. And that is at -2 and 4. If that's the case, then we can plug in those values into this equation. When we plug those values in, we're left with our function f of x equals, we don't know a, x is still undetermined, h in this case we know is -2, so that's going to be a +2 because a negative times a negative equals a positive, squared, and then plus k in this case is 4. Now what we need to do is solve for a. We also see in the graph that they have given us 2 x-intercepts. And if that's the case, then we can plug in one of those points. Again, one of those points is at 1, 0, and then the other point is at 5, 0. With that known, if we plug in 1, 0 into this equation, then we're going to get 0 equals a multiplied by 1 plus 2 squared plus 4. 0 equals a times plus 4. Move the 4 over, we get -4 equals a times 9, and therefore a is equal to -4 over 9. Now we can plug that back into our original function, so we get f of x equals -4 over 9 multiplied by x plus 2 squared plus 4. And this is our standard equation for a parabola with a vertical axis. We know that this is right because it matches the information that we have in the graph. We see here that the vertex, again, would be -2, 4, which is what we show here, and that's shown in the graph. And then next we see that it's also opening downward, which we can map to our a value because that's negative and less than 0. Also, we know that it passes the point 1, 0, and if we want it to, we can also plug in that point 5, 0 and see that it passes through also. And there you go. Now you know how to find the vertex of a parabola. You are also able to turn the original standard form of a quadratic equation into the standard equation for a parabola with a vertical axis. Remember, the key to solving for the vertex of a parabola is to understand how to complete the square. And then also you're able to determine if the graph is opening upward or if the graph is opening downward based off of your value of a. If you have any questions, please leave them in the comments below. If you learned something, please like and subscribe, and we'll see you next time.